Hi everyone. Today we are going to talk about 5.3a polynomial long division. So we are going to divide the polynomial by a binomial using polynomial long division. Before you start, I want you to try this integer long division. Can you divide 4027 by 12? I believe you know how to do this, right? You learned it in the elementary school. All right, let's go over together. So if you divide 4027 by 12, it's the same with 4027 over 12. So this is a division bracket. Then how do you put the numbers? Where does 4027 goes? Here inside, right? Dividend. How about the 12? Divisor go here. So you put the 4027 and 12 here. And then when you divide, so first go by, let's see the first 1,000 digit, 4. Can 12 go to the 4? No, right? Then you skip to the next 100 digit. 100 digit, you see the 40. How many 12 go to the 40? Yes, it's 3. So 3 times 12 is 36. Right? Then what do? You subtract. You subtract 40 minus 36 is 4, but you need to bring it down, the next number, right? Bring the next number down. That's why it's a 42. But 40 minus 36 is a 4. And they pull this number down here, 42. Then how many 12 goes into the 42? Yes, again, 3, right? So 3 times 12 is again 36. And if you subtract this time, 42 minus 36 is 6. And then bring the 7 down here, 67. Now how many 12 goes into 67? 5, right? 5. So you put the 5. And then it will be 60. And you know 7 is here. Now you cannot do any more because there is no more number. Then you are done. So what is the 335? 335 is quotient and remainder is 7. Everybody get it right? So you can write down like this. 4027 is like 12 times 335. The divisor times quotient. And then you add the remainder. It will be equal to the original number, 4027. Or if you divide 4027 by 12 is equal to what? 335. And the plus remainder 7. But when you write down like this, you should also divide by the 12. It'll be equal to like this. I needed to remember how to express both the way. Everybody get it? Now let's move on to today's lesson, polynomial long division. So polynomial long division, what is it? An algorithm for dividing one polynomial by another of equal or lesser degree. Mostly we are going to divide by binomial in Algebra 2. So this process is very similar to the integer long division. So if you remember how you divided in the do now, it'll be easier. All right, so let's see the example. So 8x cubed minus 12x minus 7, we have a polynomial here. And then we are going to divide it by 2x plus 3. So how do you do it? So even though there are long steps are here, right? But it's a simple, just follow like an integer long division. So let's rewrite so this is a bracket, division bracket. And we put the 8x cubed minus 12x minus 7 in here, right? So what do you notice? Here's a big space between 8x cubed and 12x. Do you know why? Yes, when you divide, you should make sure every degree must have their own space, place. So this is for x cubed. Next is like a x squared. x and just a number. So degree by the order of the degree 3, degree 2, degree 1, degree 0. You should make sure they have their own space. Like when you divide in the integer long division, thousands, hundred, tens, ones place like this, right? And then we are going to put the 2x plus 3 divisor where? Here. Now, when you divide, what do you do? So look at this first term in the divisor, and then 8x cubed. Think about it now, because remember, right? So remember, in the integer division also, you multiply this divisor times the quotient, right? Integer times, divisor times the quotient becomes the polynomial. We are going to use it. So we are now focus the first term only, first term. 2x times what will make 8x cubed? Anybody get it? 2x times what will be 8x cubed? So 2 times 4 is 8. X times what is x cubed? 4x squared, right? Then we are going to write down 4x squared, but x squared is a degree 2, so above here, not above the cube. It's a place of the degree 2 here, right? So right above the, degree 2, you put the 4x squared. So we are going to multiply these, and it'll be exactly the same with 8x cubed. But you should do the same thing for the number 3 also. So you should multiply 3 times 4x squared is 12x squared. Now what do? We subtract, right? When you subtract, what happens is this and this will cancel always because it's exactly the same. Then if you subtract, here's 0 minus 12x squared is negative 12x squared. And then we bring this down, right? We bring this down. So this is negative 12x squared minus 12x. Now we repeat the same steps again and again, right? Now let's focus again the first term, 2x and negative 12x squared. So now what should we do? 2x times what is negative 12x squared? Can you get it? 2 times negative 6 is negative 12. X times x is x squared. So negative 6x, you write down here, right? Negative 6x. So that will be negative 12x squared. At the same time, you need to multiply 3 also. 3 times negative 6x will be negative 18x. You understand, right? Then what do we do? Yeah, you subtract. When you subtract, negative, exactly the same thing here, right? You are always getting the same thing here. You're supposed to get the same thing. Then if you subtract, 0. Now, negative 12x minus negative 18x minus negative become plus 18x, right? And if you combine negative 12 plus 18 will be 6x. And then we bring the 7 down with a minus. Now, finally, 2x times what is 6x? 2x times 3, right? Plus 3. Then 6x. And then also you multiply 3 times 3 is plus 9. So you write down 6x plus 9. And then what do? You subtract. So negative 7 minus 9 is negative 16. Then we are done. So there's no more x, right? Then you cannot divide anymore. You don't need to go further. You stop here when you have only number here. So your quotient is 4x squared minus 6x plus 3. And remainder is negative 16. Does everybody understand? Again, So this is the quotient, this is the remainder, right? So now, I believe you know how to divide integer division and polynomial division. What do you notice here? Can you figure it out? Looks similar, right? 6, 6, 7, 7, 2, 2. 100 digit become x squared. Tens digit 7x, x. So x work like 10, right? When you divide. So 2 times 10 is 20 plus 1 is 21. Does it make sense to you? So can you divide both? And then you can see what's going on there, right? So let's try together. So we are going to divide this at the same time. So how many 21 go here? 3, right? 3 of them. So 63. How many 2x goes here? 3x. So 2x times 3x, 6x squared. And then you should multiply 1 times 3x is 3x. Then what do? We subtract. 7 minus 3 is 4. And bring the 2 down. 7x minus 3x is 4x. And bring the 2 down. 42, 4x plus 2. Interesting, right? How many 21 in here? 2 and 1 times 2 is 42. Likewise, 2x times 2 is 4x. 1 times 2 is 2. Oh, exactly both of them exactly same. Then if you subtract 0, 0, right? So remainder is 0, both of them. So quotient is 32. And here is quotient is 3x plus 2. Do you see any connection between these two divisions? Yeah. 3 times 10 is 30, right? 30. So x is like a 10th digit. Then 10 times 10, 10 square is 100 digit, x squared. Does it make sense to you? Good. So if you want, you can use it. But if there's a minus, kind of is a little bit complicated. So but when everything is a plus, you can work this way. So 60, 72 is 21 times 32, right? Or 672 divided by 21 is 32. And polynomial also 6x squared plus 7x plus 2 is equal to what? Divisor times quotient. And remainder 0 plus 0 is nothing. Oh, it's like a factors, right? These two are the factors. And then if you divide by this is a quotient. Do you understand? Okay, we'll stop here.